Hi everyone, welcome back to Artificial Intelligence class. This is the second part of our Unit 1 and today we are going to discuss about AI techniques. What is your AI technique? AI technique refers to a set of methods and algorithms that are used to develop intelligent systems that can perform tasks requiring human-like intelligence. These techniques encompass various approaches like machine learning, NLP, computer vision, and deep learning. Discussing about machine learning, NLP, computer vision, and deep learning, these are called as artificial intelligence techniques. And first, we will discuss one by one about machine learning first. And machine learning is one of AI foundational pillars. And this technique encompasses computers to learn from data and improve their performance with the time without explicit programming. ML models can make accurate predictions and decisions through supervised and unsupervised learnings, impacting everything, everybody, and every learners to have a personalized recommendations for fraud detection and other applications as well. Next, when you discuss about natural language processing allows machines to comprehend, interpret, and generate human languages. This AI technique has paved the way for virtual assistants, chatbots, and language translation tools, making communication between humans and machines more seamless than ever. Third is computer vision. Computer vision AI technique enables visual informations from the world. This technique has revolutionized industries like healthcare, automotive, and robotics, and enabling tasks such as facial recognition, object detection, and autonomous driving as well. And finally, it is a deep learning. And deep learning is an improved version of machine learning, and which is going to perform a high level machine learning task by employing neural networks with multiple layers to process complex data representations. It has propelled AI achievements such as beating human champions in games like chess and Go, like we had discussed in the last class itself, like AlphaGo, and enhancing image and speech recognition systems. The next topic will be problem solving with AI. Why problem solving is important? What is problem solving? The process of finding solutions to difficult or complex issues. Okay, finding a solution for a problem is nothing but a problem solving. And artificial intelligence aims at making such systems which are capable of solving various problems on its own. AI problem solving is a process where an AI agent tries to reach a goal with an intention to find the solution to certain problems. The problem category during problem solving, the problem categorization can be categorized into four types. One is structured problem, unstructured problem, linear problems, and nonlinear problems. What is a structured problem? These problems yield a right answer or right inference when an appropriate algorithm is applied. These are going to yield only a structured outputs solved in a step-by-step manner. They are known as a structured problems. Unstructured means these are problems which do not yield a particular answer. It may have got two or more answers. In this case, there is a probability for more than one answer, and even a particular situation decides the correctness of the answer. And third will be your linear problems. It is a problem which can be solved or where decisions can be obtained by linear solution. A linear, mathematical linear solution, like it follows a linear graph. So for example, voltage versus a current equation. If you just draw a graph, that graph will be linear curve where voltage increases and the current also will be increased. They are directly proportional. So the linearity will be reflected in the particular examples. Those kind of problems falls under linear kind of a problems. The last one will be nonlinear problems. It is the problem which cannot be solved or separated by linear equations. So as we discussed, the structure problem are categorized into two types of problems, well-structured problem and ill-structured problem. In structured problem itself, we have two types, well-structured problems and ill-structured problems. What is your well-structured problem? Well-structured problems are um, structured in a step-by-step fashion, and they are going to yield a correct result. That is, the answer also going to be only one. So, for example, solving a quadratic equation to find out the value of x. So, in a partial differential equation solving, finding out of x with respect to different values or parameters, we are going to follow the same procedure, and the result is going to be obtained for the values of x or y. So, they are actually going to follow the same steps, similar steps. For whatever may be the problem, whatever may be the parameter, the steps are going to be the similar. So it is step by step solving the problem and finding the solution for X. This is called as, and it is going to yield a particular answer. It is not going to yield some other answers. Two different answers will not be considered as an correct answers. So only there will be an only one correct answer. This kind of problem are called as well-structured problems. Other examples for well-structured problems could be calculating path of the trajectory when a missile is fired. And the third example could be calculating speed of a ball when it reaches to batsman. And also network flow analysis problems can be considered as a well-structured problems. So if you consider well-structured problems, no, it follows an orderly steps and it is going to either yield a correct answer or incorrect answer. It cannot have multiple correct answers. Next, ill structure problem. Ill structure problem is just contradictory to structure problems. They'll be having more than two answers, can be the correct answers. Depends upon the perspective. Based on the perspective, based on the situation and scenario, person to person, the correctness of the result could be varied and both will be an accepted answer. These kind of problems are known as ill structure problem and they do not follow the structured way or a step-by-step manner of solving the problems. So, for example, predicting how to dispose wet waste safely, an analysis of theoretical propositions and adequacy of the same in particular scenario, and identifying the security threats in big social gatherings. These are all some of the examples for ill-structured problems. Like there is no, if you could see this diagram, there is no orderly steps and also analysis for, it is analysis subject to the output is going to be analysis for correctness. It is going to yield two or more answers. So which is the correct answer is for subjectiveness. And one example for the well-structured problem would be a tic-tac-toe problem. This game starts with one of the players and the games win with one of the players has one who row, column, diagonal filled with his respective characters O or X. If no one wins, the game is said to be draw. If X wins, X can be positioned horizontally together or diagonally together or vertically together. So if X wins, O is losing and neither of them wins, it's going to be a draw. So this is how tic-tac-toe problem works. This is the initial state. First, let the X place. So if X can play it at this position or at this position or in this position. So with respect to X played here, the state space has been elaborated here. When X is playing here, the state space has been given. When X is placed here, this is the state space. The next turn would be, as of now, in this step, there is no one is winning. So, and also the game is not yet stopped, ended. So we have to progress further the game. The next player would be, the next turn goes to O, player O. So where O could be played, O in this particular state, the O can place it here or here. Similarly, in this state space, the O could be placed here or here. Similarly, in this one, the O could be placed here or here. So with respect to all those combinations, you expose the state spaces with the O here, O here, O here, and the O here, and here also the O here and the O here. So that what will happen is, this is the state space we have been arrived. Even now, the game is not yet completed. So we have to complete the game. The next turn of completion would go to what? X. So X can be according to this state space. The X could be placed here according to this particular state. The X will be here, and according to this X will be here, and according to this X will be placed in this empty space. So after placing them all, you can see that in all the positions who would be the winning and who will be the losers. If you could consider this particular state, it's going to be a draw. So if it is a draw whose points, whose winning score has been considered as zero. Okay, no one is winning, right? So the match score will be zero. If X is winning, consider we are seeing the game with the perspective of X. So if X wins, it is plus 10. The score would be the point who's earned by X is 10. If the O is winning, then it is going to be minus 10 for X, which means the O has won the game. And here as well, if you see this particular state, no one is winning because diagonally or vertically or horizontally, no same player has positioned its coins. So it's going to be neither of them is winning here. So the result of the game would be zero. This is what tic-tac-toe problem. This is actually an example for well structure problem because it is going to yield definite results. Three of the definite results like winning of X, winning of Y, winning of O, and then drawing a particular game. Then the next topic is AI models. So what are the AI models? First AI model is Maze hypothesis. So Maze hypothesis has been introduced by Dunker. This is as part of psychological theory he has introduced. In this particular hypothesis, the creative intelligent task handled by human beings are modeled like a set of maze of paths. So what the problems which we are going to solve is being structured by Maze hypothesis. So how the Maze hypothesis will be solved, accordingly, the problem has been approached. So with the initial states and leading to a resultant state by multiple ways of exploring this path from the start to end. So if you consider a maze paths, at the start, we may enter, we may not know where is the receiving end, and we know only at the entrance, and there are various paths would be available in order to reach the goal. And since there are multiple paths, we may just end up going into multiple paths before reaching the goals. We may be going to right or left. If at all we go for right, and then we may just start ending up here, and then here there is a wall. So again, we have to come back to some other path. So like a zigzag manner with these complex paths, everywhere will just move on front and forth. Finally, we will be reaching the goal state for after a Hazel traveling experience. So what will happen is if you have traveled once you have reached the goal, what will happen next time you try to travel, you will reach the end state much easier way, much quicker way. So again, if third iteration, what will happen is much quicker way because you know that in what direction the end goal is. And if you follow unnecessary tracks, you will not be moving into only the required paths and what direction you have to move. All that you will be able to have an idea. These kind of learnings from following the maze path and modeling problems with respect to these maze paths and finding the solution the way the maze has been solved is a kind of problem called as maze hypothesis. So in maze hypothesis also, we can create the entire maze structure, entire maze area into a matrix. All the ways can be drawn as a segments by considering nodes in the empty spaces. And you can have the units on x-axis 0, 1, 2, 3, 4, 5, etc. Similarly, on y-axis, And wherever the paths are there, so paths are actually through the paths we can walk through, right? So these paths can be connected through some nodes. So with the starting of one node, and then you can have with equal distances, another node could be connected. Similarly, yeah, with the available another path can be connected with another node. So you can just make that entire maze path into this kind of nodes and segment structure. From this nodes and the segment structure, it can be created a tree structure. To create a tree structure from this 2D plane is very, very easy by connecting, how the nodes are being connected. With respect to that, a tree structure could be drawn. For example, if this node can be accessed, referred as by 1, comma 0. This node have coordinate points of 0, comma 0, and this node could be referred as 1, comma 1. This node could be 0, comma 1. This node could be 4, comma 0. Similarly, all the nodes can be referred with respect to the coordinate points of x value and y values. So with respect to the connections, you can just convert them into an tree-like structure starting from 1, comma 0. So it's 1, comma 0. After that, where it leads, where it's progressing, assume that this is a start node, and your 4, comma 0 is the goal state. So start from the initial state 1, comma 0. From 1, comma 0, where it has been connected 0, comma 0. After 0, comma 0, where it is going, it is 0, comma 1. After 0, comma 1, where it is going 1, comma 1. If you consider 1, comma 1, it moves to this particular node where it has got multiple branches. So make that node as a common node, which is nothing but 1, comma 2. From 1, comma 2, one branch is 1, comma 1, another branch is 0, comma 2. So 0, comma 3. Similarly, you just create a tree-like structure. After creating a tree-like structure, it is very, very easy to solve this maze hypothesis, because if at all your starting point is here, you have to reach 4, comma 0. It is very easy that you can reach via from here 1, comma 0 to 0, comma 0, 0, comma 1, 1, comma 1. Then 1, comma 3, 2, comma 3, 2, 2, 3, 2, 4, 2, 4, 1, 4, 0 could be reached easily. Unnecessarily, you don't want to go to 02, 03, 04 and all, because we know that we have to reach 4, comma 0. So this is what the solving the problem using maze hypothesis. Clear, right? So next AI model is going to be the logical analysis. Using logical mission also, the AI problems will be solved, because all computers will be using the logical gates. And with respect to the logical gates, many problems could be solved. Like in logical gates itself, there are so many analysis like AND gate logic, OR gate logic, imply logic, NOR logic, all those. So using those logical functions, logical truth tables, we can able to solve many problems of computers, and this will be used in controlled environment like chess and create many other games. Like for example, for a NOT logic, the NOT logic, this would be the NOT logic, and the NAND logic means it is a combination of two logicals, that is and or, wherever is the wherever both the conditions are not satisfied, then it is a not NAND logic. And means when both are satisfied, it is an AND logic. And even though all combinations of true and false included, it's OR logic, and NOR logic will be exactly complement of OR logic. None will be included in NOR logic. And imply logic, imply for B means, wherever the B content is there, the entire B content will be selected for imply logic. And imply logic will be complement of that. And XOR would be except only the positions which are not included of A and B would be the XOR logic, and XNOR will be complement, exactly the complement of that. Next is going to be AI model building and knowledge mapping. See, there are two primary aspects in knowledge building. One is model building, another one is discovery. Model building is creating a knowledge-based systems and AI applications, whereas discovery focuses on identifying relationships and mapping knowledge for problem solving. The interplay of these elements showcases the complexity of AI modeling, which requires both structured knowledge and adaptive applications. There are different categories for AI efforts based on AI knowledge-based agents based on the complexity. The diagram provides a conceptual framework for understanding the relationship between discovery and modeling processes. So, if you see here, in terms of complexity, knowledge-based modeling, there are with respect to model and with respect to discover, based on the complexity, the relationship would vary. Okay, so if the discovery relationship will be having low complexity, when complexity increases, the discover knowledge will be called as a mapping. And the model based knowledge, when complexity is less, it is referred as a knowledge based model building. With a more complexity, the same model building could be called or AI application building. So the AI models, what are the four models we discussed? Knowledge based model building with low complexity, discover relationship with low complexity, AI application building with high complexity, and a mapping which is discovery based. So model based knowledge agents and then discovery based. In discovery based with less complexity, it is called discover relationship. With a high complexity, it is mapping. And for model based with less complexity, it is knowledge-based model building. With more complexity, it is AI application building. So if you see AI models, there are four key areas of AI models. Knowledge-based model building. As we discussed in the previous diagram, no, clearly the four types of knowledge-based model buildings. The first one will be knowledge-based model. So knowledge-based model is a structural model that is informed by a domain expertise. It involves, already we discussed about, this is a low complexity model. It works based on the predefined knowledge or rules. For example, a rule-based expert system used for medical analysis, where relationship between known facts or concepts are represented and utilized for problem solving. For example, the example is being given portrayed even in the diagram here. For doctor medical report analysis, you can create an AI agent with certain prompts, like with respect to the various parameters. The prompt has been trained, the model has been trained. For example, skin rash, fever, headache, cold, cough, vomiting. With respect to these inputs, the model has been trained, and based on which it suggests the doctor that these kind of diseases are possible. This kind of an agent is called as knowledge-based agent, where based on the knowledge of these parameters, it is discovering the disease probability and giving an output. This is called as a knowledge-based model building. And the second kind of a model building is AI application building. AI application building is an advanced system. Complex level is more. And this system is developed by integrating multiple AI components. For example, Tesla kind of cars, autonomous cars. It is revolving around many AI parts. It's not that for car building, we will be able to use only one AI component. There are multiple AI components will be used for steerings, then safety purposes, seat adjustments, wheel adjustments, and then for braking, and for all those is for ABS control. For all these various applications, you will be using multiple AI systems. So to connect all these multiple systems, those technologies that are enabled with vision, navigation, and decision making should be effective. So this is a sophisticated model because many coordinations required with respect to all the different AI paths with the different AI technologies. So this is a broader domain. And then the third AI model. So let's move on to third AI model. This third AI model is discovering relationship. So discovering the relationship, this is less complexity model in the category of discovery. So it is focuses on extracting patterns. Okay, extracting patterns are deriving some fruitful data from the available input. The input may be a raw input, and we have to convert them into a structured data. So, like for example, a clustering of clustering of fruits, from the bucket, from the basket basket that contains many fruit varieties. Your objective should be segregating them into different, segregating them into a particular group, like uh, particular group. So this is called as a discovery relationship. So thank you all for with this we are ending today's class with AI models.